Welcome. In this video I'm going to show you how you can perform a power divergence test with R. I'm using stikpetR Notebook to show you how this can be done, but the R code can of course also be used in RStudio or any other IDE you're using. This video will focus on using third-party libraries to do this. Actually, my own library is preferred, and we'll just mainly focus on how you can perform the test, not if you should be performing the test. And the power divergence is, I think, from cressie-read. Here's the formula. It's actually the last one. That's the main one. It's using a lambda, and by setting a different value for lambda, you get actually quite a few different tests. There are two special cases, because if this first fraction becomes 0, there's a problem, because then you're dividing by 0. Alright, because it's using a chi-square distribution, there are some who give some recommendation on when you should use this. Or some condition for it about minimum expected counts. I won't dive too much into that. There are also corrections that can be applied, because it's usually used for a discrete situation where you have counts, and the chi-square distribution is a continuous distribution. So to show you how it can be done with R, let's load in an example. I have a data file from the General Social Service. I adapted it slightly, and just to show you the first 5 rows, here they are. Don't worry about this double character, etc. That's only in stikpetR Notebook that's actually being shown. It shows what kind of data is in each column. I don't need all the data, I only need the marital type as the example, so I'm going to call that field 1. And we can get a quick impression of what that looks like. We're using the frequencies command, the table command. I stored it as frequencies, and we can see that 972 people were married. For a test of independence, you need, of course, 2 fields. So let's use the gender option as well, and create a cross table out of that by again using the table function. And here you can see that, for example, 456 people were married and male. Now, for performing the power divergence test, I actually made my own function. It's not on CRAN, so if you want to install it, you can install it from my GitHub. To do that, you need the DevTools package. If you've never installed that, then just run this line, uncomment it. Then use this line to install it from my GitHub, and then you can actually load the library. I've already, of course, installed it, so I'm only loading it. The function has 2 variables as input, or the second one is actually optional. If you only feed it one, it will do the goodness of fit. Otherwise, it will also do the independence. You can specify the expected counts, but you can also leave it empty. And you can, of course, specify the lambda that you want, either by entering a specific value or some descriptions, which will then set the lambda for you. The correction can also be done. None is the default, but you can go for a Yates, Pearson, or Williams correction. So you then simply load the function, or call the function TS, short for test, power divergence, and for a goodness of fit, just the one field, and we get the output as a data frame. It shows the test statistic, the degrees of freedom, the p-value, also known as the significance, the minimum expected count, and the percentage of counts that were cells that were below 5, and a small description of the test that was actually used. So that's actually all the output that you would need. For a test of independence, you can just feed it the 2, and you get the same output, or, well, different values, but the same columns. So you have all you need to interpret the results and also write them down. There's only one other library that I've seen that has something even remotely similar, which is the MSC Quartet. They have a power divergence function. It's quite limited, as in it can only be used for the goodness of fit version, and you will have to no corrections, and you actually have to calculate the expected counts. You can load the library, first of course install it, and then you can use its function. It does need those expected counts, so you can quickly get those by doing the sum of the frequencies and the number of categories, and then simply do n over k and repeat that k times. So then we would assume that each category had the same frequency. Then when you can use that function, and it gives the same test result. Then if you want to see the p-value, that's not too difficult. You can determine the degrees of freedom for goodness of fit, which is simply k minus 1, the number of categories minus 1, and then use the p-chi-square function, which is in the rstats library, and it should give you the same result as we saw earlier. If you also want to do the corrections, then you probably will be having to use the formulas. I will make a separate video on that. If you are interested, it also shows the comparison with the original formulas. And I think that's about it for this video. Hope this was helpful, and thank you for watching.